All right, so for my honors students, this is the skill that you're going to be tested on with Unit 3. We want to talk about the expanded model of the atom. So if you look at the picture here on the screen, this is the Bohr model. So we talked about that electrons aren't just floating around in space, they are actually in defined orbitals of varying energy, and the electrons can move up and down in these orbitals. So if we had an energy, they can move up to the next one. And actually, we talk about them settling back down and emitting light, but we didn't get into that too much. But the idea is a scientist came along, a mathematician came along after that, and his name was Schrodinger. Erwin Schrodinger actually was a physicist, mathematician, and he said, you know what, Bohr, I like your model, but instead of this idea of the electrons actually being point charges or matter, or particles, he said, well, really, electrons are kind of like light, they're waves. And so we're not going to talk about these electrons being in a particular point, but let's talk more about their probabilities of being at a certain location. And actually, there's a Schrodinger equation, which is advanced calculus, that talks about if you know the approximate location of an electron, you don't know its velocity. But if you know its velocity, you don't know its location. So it's kind of, if you know one, you don't know the other kind of thing. So the idea is we want to talk about these electrons not being necessarily these circular or spherical orbitals, but we want to talk of them about lying in these clouds of probability. So the idea is an orbital is not actually like this finite spherical where an electron goes around, but it's this cloud where the electron could actually be anywhere within this cloud of probability. And the darker the cloud, the more likely it's in that position. So there's a little picture here of one of the orbitals, but the three we really want to be able to describe at least a little bit are the s, p, and d orbitals. So we should all know for the exam that s orbitals are actually spherical. If you look in the top left of the screen there, they are basically balls. They're spherical, they're small. S orbitals we know will only hold 2 electrons, and they basically lie a sphere off of the origin, the 0, 0, 0 point of the x, y, and z plane. The p orbitals, which we see here, there are 3 of them. There's the px, or p sub x orbital, that lies along the x-axis, and it's kind of like this double-ended pair. The same thing, or they call them nodes a lot of times. The py is along the y-axis, and the pz is along the z-axis. So again, each of those will each hold 2 electrons. So the p orbital we know holds 6 total electrons. And on the bottom, they show all 3 of the p orbitals together, and it's basically like this 6-pointed node along the origin, going along the x, y, and z axes. So we really want to have an idea that the s orbitals and then the p orbitals, what they look like, their shapes, and kind of how they lie. And finally, we'll talk about the d really quickly. I may have you identify one of the d orbitals, which my favorite one is the dz squared. That's the one right in the center. So again, the d orbitals, there's actually 5 of them. So each holds 2 electrons, so there's 10 electrons in a d orbital. And you can see most of them fall in between the axes. So the dyz falls between the y and z axes. So you can see it's perpendicular to the x. The dxy is along in between the x and y axes, again perpendicular to the z, and the same thing with the xz is along the xz axis. The dz squared is again right on the z axis, but also has this, tubular thing around it. That's why I think it's so cool looking. And then the dx squared minus y squared are actually the ones that are on the x and y axes. So again, these are just areas of probability where electrons may lie at any point in time in those orbitals. So within that dx squared minus y squared, if it's full, there are 2 orbitals somewhere in those clouds. So you can see a lot of this gets into very advanced like orbital diagrams and bonding diagrams when you get into more advanced chemistry, which we definitely will not cover in this class. But it's kind of interesting to know that then those nodes, these little clouds of probability, when atoms bond, they overlap. So the idea is now there's an area where both orbitals from two different atoms come together and there's overlap, and that's where we get the bonding from. They're overlapping their clouds, so they're sharing that electron density. So that's it. So for the exam, definitely know that Schrodinger upgraded orbitals from these spherical circular orbits to clouds of probability, and that we have three types we've talked about. The S are spherical, the P are those nodes that lie along the X, Y, and Z axis, and again, I'll probably give you the dz squared just to identify. So just be able to say, well, that's a d orbital. And if you say it's a z squared, I'll be really happy. But as long as you say that's a d, it's a little different from the pz. So that's it. I'm going to load this video now on the website, and make sure you review it so you can get full credit.